So I'm here today with Rowan Williams from BASF. We're talking about compostable polymers. Rowan, can I get you to introduce yourself and your various roles in the industry?
Sure. Thanks, Jed. Morning. So I work for BASF Australia, and I'm in charge of regional market development for biopolymers, as we call them, for Asia Pacific. So I look after all the countries in Asia Pacific, and I support market development in China. In addition, I'm also the president of the Australasian Bioplastics Association that represents members on advocacy and stakeholder management for all types of bioplastics. I'll explain different families shortly. And I'm also a director of the Australian Organics Recycling Association to help educate and familiarise the organics recyclers on the use of specifically compostable plastic.
And you mentioned different families of biopolymers. What sets them apart? What are the differences between the various biopolymers?
You have fully bio-based conventional plastics, if you like, where the carbon source has been replaced with a renewable material. So, for example, instead of PE or PP, which you'd be familiar with, we replace the carbon with sugars or other fermented renewable raw materials to make bio-based PE, polypro, polystyrene, polyamides, and so forth.
Okay.
And are designed for the conventional or mechanical recycling streams. So a bio-based PET, for example, is indistinguishable from an oil-based PET. They can be processed together and has no impact on the recyclers. So that's that family. Definitely designed not to be composted, do not have the inherent properties of biodegradability. They're designed for the conventional recycling streams. The other family is, of course, those that we refer to as compostable and preferably certified compostable, being certified to one or other or both of the Australian standards destined for organics recycling or composting or AD at end of life. So they're very distinguishable. We have fully bio-based for conventional mechanical recycling, and we have certified compostable and therefore biodegradable, destined for organics recycling. The only way to prove that something is biodegradable is to have it certified compostable, where the biodegradation tests sit within those standards.
With certified compostable being very important, as you discussed, that's about end of life. What applications are then suitable for compostable polymers?
So the base rule or the base philosophy is packaging or containment of food waste. So let's look at it, say, from your caddy bin liners on your kitchen bench, or maybe a compostable garbage bag in a restaurant or commercial premises, where food waste can be source separated into that bag and go off with green waste or other food waste or organics collection. Food service type items is an application today. We'd like to think that more problematic packaging that today is condemned to landfill because it's food soiled or had food cooked on it, or howsoever the food is there, then a package like a tray or a freezer chip bag or whatever you might find in your pantry or in your freezer that contains food, which today, because it's contained food, renders it neither reusable or recyclable, then that might be an application for a compostable polymer. But there's obviously a lot of thought that needs to go into that, because you have to think about barrier properties. We don't want to increase spoilage of food. So there's a lot of things you need to work through to make sure that it's appropriate.
For a lot of our customers, film manufacturers, injection molders, people that may be looking to use compostable where it is a suitable solution to a problem that their customers have. A lot of questions we get is around, well, okay, what does that polymer look like? How do I process it? What are the end properties versus a conventional, say, polyolefin or other polymer that they're using?
Okay, well, largely speaking, I mean, I'll use BASF as an example. We have our EcoFlex and EcoVO, for example, and it's similar to a lot of other products out in the market with different trade names. But essentially, they process exactly the same as polyethylene on conventional equipment. There may be minor changes such as temperature and speed and other processing factors, but largely they process in the same way on existing equipment.
Yeah, and I guess the experience we've had in seeing those polymers used, that's certainly what we've seen. That in the end, it's not too much trouble to be able to make the product the customer's looking to make.
Yeah, we've had quite a bit of experience, obviously, with film grades, because the market in Australia for compostable plastics for, 10 or 12 years that I've been involved has all been about bags and monolayer films for organic waste bags or poo bags or whatever they might be. It's been very commoditized. It's all been very monoculture. But we are now seeing trends into more multi-layer, where we can have a compostable film and a compostable barrier film, and different structures are being developed all the time. And that's moving at a pretty rapid rate. We're moving into, not just we, but the industry is moving into more compostable coatings for paper and cardboard to replace problematic packages. And then, of course, we have agricultural mulch films that are certified soil biodegradable, probably a bit off the topic today, but they also exist. And they also run exactly like PE as well. But of course, the advantage in a biodegradable mulch film is you don't need to collect it after use. You can leave it on the soil. It will completely biodegrade. It will turn into CO2, water and biomass and be fully assimilated by microorganisms in the soil. But we don't support the replacement of PET water bottles, for example, whether or not there's a problem in recycling them or collecting them today. Making a compostable PET, not PET obviously, but a compostable water bottle really doesn't add any value at all, when PET and other conventional plastics is theoretically a very robust recycling stream, and we don't want to interfere with that. So I go back to that base premise. If it's been in touch with food, and that therefore renders it non-recyclable, non-reusable, and compostable, might be an alternative. And there's a lot of inquiry level, probably to you from your customers, and certainly from mine and other stakeholders in the whole industry, is what are these future applications going to look like? How do you measure appropriate? Well, we've had applications for compostable shoes. I'm not sure that makes a lot of sense. We do get a lot of inquiry for replacing PET water bottles with compostable solutions, but we politely and professionally disappoint those people, and that's probably not an example of an appropriate application. You really want to capture these packages or items, whatever they are, that today, even under the packaging covenants, aspirational targets of 100% of packaging needs to be recyclable, reusable or compostable by 2025. In reality, compostable packaging is going to occupy a very small share of the overall packaging market due to functionalities, forms, but not the least of which is availability of material. So today, compostable plastics are largely sold out. Demand is outstripping supply. There is new capacity coming online, but it isn't millions of tons. It's hundreds of thousands. There's a lot of reports in China about millions of tons coming online, but we don't see too many plants being built yet.
Okay.
So wait and see.
Right. And so giving compostable polymers does have a role, as you mentioned, within the 2025 APCO targets. It's important for us as an industry to then direct those polymers that are available into the applications where it's really suited and has the correct end of life. Outside of the recycling stream of conventional polymers.
Yeah, I think we need to equate in the waste hierarchy that organics recycling is equally an option as conventional recycling. And given that conventional recycling has its own issues at the moment in terms of the China national sword, trying to get capacities to recycle more conventional plastics, it still should be done. But the organics recycling industry exists today. It processes 7.5 million tonnes. It's a $2 billion industry. It's not exactly a backyard operation.
Right.
And that's at a recycling rate today of organics and things of around 50%. If you could move that needle to 90, it could be a $4 or $5 billion industry doing, 15 million tonnes. So there's a lot of scope to improve. And compostable plastics, in terms of capturing food waste, whether it's the bag, the package, whatever, really does help that source separation and improves that sector. And I'd quickly add for the organics recycling industry, it produces domestically, it employs domestically, pays tax domestically, sells domestically, and solves a domestic problem. And it doesn't need China or other places to send its product to.
Yeah, and compostable polymers, no doubt, increase supply into that industry as it's directing food waste to that industrial compost.
Well, as we get more FOGO in more municipalities going and people get their head around that organic waste to landfill is just a dumb idea on so many levels, if you have a robust organics recycling stream for food waste, then compostable package can also go curbside. And in whatever form it takes in addressing that most problematic package that today goes to the landfill, creates the innovation space for us to come up with a package that can solve that problem and send it to organics recycling.
Yep.
Just because it doesn't exist today doesn't mean it's not coming. There is a lot of work in that area. But what is that final problematic package solution going to look like? Well, that's what we're all working on.
Fantastic. Well, it's obviously exciting time in that industry. So, thanks for sharing your information with us, and really appreciate your time today. Thanks a lot, Rowan.
Yeah, thanks a lot, Jed. Been great. Thank you very much.
Cheers.